Welcome aboard Rocket Ship, the platform with the most relevant content for competitive examinations. This is Rocket Ship IAS Lab and continuing with our series on answer writing for general studies papers of civil services main examination. We take up a question that you might come across in GS paper 3. Here goes the question. What makes the entire coastline of India vulnerable to tsunami? Discuss the measures in place and steps that can be followed to reduce loss of lives during a tsunami. So, you do understand that India being a peninsula has two major, you could say, seaboards, basically the eastern seaboard as well as the western seaboard. The question tells you that both the seaboards, that is both the seaboards of India, the eastern seaboard as well as the western seaboard, are vulnerable to tsunamis. The question requires you to talk about what would have been the reasons, what are the reasons due to which both the coasts, almost the entire coastline of India, is vulnerable to tsunamis. Then the second part of the question requires you to talk about what measures are already in place and what steps can be taken during a tsunami, as you can make out from the wording of the question, what can be done during the tsunami to reduce loss of lives. We are introducing our answer with briefly defining tsunamis and their characteristics. Tsunamis are a series of abnormally large wavelength waves in large water bodies. The tsunamis, unlike tides, which are result of gravitational pull on water, are caused by sudden displacement of enormous volumes of water. So this is a basic difference between tsunami and other phenomena in the ocean, or for that matter water bodies. That is, unlike tides, which are mostly gravitational phenomena which are caused due to the gravitational pull on water of the sun and the moon. Similarly, waves are generally caused due to the winds, but tsunamis are sudden displacement of large volumes of water. This makes them different from, you could say, other phenomena that we observe in the water bodies. They rise to abnormal heights. This is also important. This is a key characteristic of tsunamis. They rise to abnormal heights as they reach the coast. This is generally called tsunami run-up. Anyway, inundating deep coastward suddenly. That is, they can flood, you could say, quite deep towards the coast, under inland, quite deep inland. Forces that can cause displacement of large masses of water also generate tsunamis, as we have just discussed that tsunami is a result of displacement of large volumes of water, and the forces which can actually cause this displacement can also generate tsunamis. These forces are tectonic phenomena like earthquakes and volcanoes, or for that matter the plate movements, landslides into enclosed bodies of water, and meteorite or asteroid strikes included, to name a few. These are some of the phenomena which can actually cause large volumes of water to be displaced, resulting into tsunamis. Both the coastline of India are vulnerable to tsunamis as they are active plate boundaries along both the Arabian Sea and the Bay of Bengal Andaman Sea. So we have just discussed that tsunamis can be caused due to the tectonic phenomena, for example earthquakes, volcanoes, or for that matter the plate movements, etc. And as both the seaboards of India do face active plate boundaries, that makes them vulnerable to tsunamis. That is the basic reason why both the coastlines of India are vulnerable to tsunami. Makran subduction zone of the coast of Balochistan is the region where the Arabian plate collides with the Eurasian plate. Sudden subduction of the plates can displace humongous amounts of water, generating tsunamis. So again, the point is, the Makran subduction zone is a zone of the coast of Balochistan and somewhat inland as well, where the Arabian plate goes under the Eurasian plate. That is, the Arabian plate subducts under the Eurasian plate, and this can actually displace huge volumes of water, giving rise to tsunamis. They are seismically active fault zones in Kutch, like the Kutch Major Fault. There are actually a number of seismically active fault zones in Kutch, one of whose examples is the Kutch Major Fault. These faults have been blamed for, we have actual evidence from history that these faults have been blamed for the 1819 earthquake and tsunami in Kutch. Similarly, coming to the eastern seaboard of India, the Sunda-Burma subduction zone lies off the eastern Bay of Bengal, Andaman Sea. That is, it is on the eastern seaboard of India, off the eastern seaboard of India. The Indo-Australian plate is subducting beneath the Eurasian plate. Beneath the Eurasian plate. The tectonic activity in the Sunda-Burma subduction zone caused the calamitous 2004 tsunami. You are almost certainly aware that the 2004 tsunami is considered the, you could say, the single disaster that has taken the largest toll of people. However, many people dispute this. They consider some other disasters to have caused many more deaths. But anyway, the point is, it was a calamitous event that was caused mostly due to the tectonic activity in the Sunda-Burma subduction zone. Now, coming to the second part of the question, how we ensure that loss of lives is limited. Ensuring that the loss of lives is limited depends on tsunami risk mitigation, early warning, and evacuation during tsunamis. Actually, whenever we talk about disaster management, there are a number of, you could say, steps. Generally, we would like to repeat it. This is called disaster management cycle. Disaster management cycle. It is generally divided into 4 stages. Anyway, and you can understand that these 4 stages actually encompass the pre-disaster event, the actual disaster time, the time just after disaster, and the recovery time. Anyway, what we suggest you that you look up the disaster management cycle and 4 stages as soon as we you could say end this lecture. Anyway, the point is, the ensuring that the loss of lives is limited depends on tsunami risk mitigation. That is, even before the tsunami we can plan to mitigate the risk. Early warning, so that we can warn people, for an example, from moving to the sea coast. They should be actually told to move away from the sea coast. And moreover, evacuation during the actual tsunami. As soon as the tsunami has struck, we have to facilitate the movement of the people, evacuation of the people. Reducing tsunami's toll comes to tsunami risk mitigation. For an example, breaking the force of the tsunami. This is very, very important because the tsunami itself is a wave. If we can actually break its force, it would mean that we can actually reduce the death toll of people. And as we would see later, it can be done, for an example, having vegetation along the sea coast that would actually act as breakwater to break the force of the wave, that is, break the force of the tsunami, and ensure that much less impact is faced by the coast. Early warning, so that we can actually warn people when a tsunami is actually developing, so that they can actually evacuate the coastal zone. Evacuation, coming to the point, evacuation when the tsunami is just about to strike or it has already struck. It means risk zone mapping. What it essentially means, that it is generally called inundation or flood mapping. For an example, it actually means risk zone mapping. For an example, suppose a 10-meter high tsunami is about to develop. So we can actually tell people, for an example, that if they moved to an area that is 500 meters from the coast, there is much less risk of them being caught up in the tsunami. They are being overtaken by the wave. We would repeat it. That is the entire cost of entire, you could say, concept of risk zone mapping, that we can actually tell people that how much distance from the sea coast they would be safe from the tsunami. Generally, as we would see later, generally it is considered 1.6 kilometer for a 30-meter high tsunami. And moreover, as you can understand, 30-meter high would mean that if you are higher than 30 meter from the mean sea level, you would be mostly safe. Basically, if you are on the 4th floor of a building, you would be mostly safe. Moreover, we have to train people in emergency responses. For an example, not to panic, because panic can often develop into a stampede, leading to unnecessary loss of lives. Moreover, people should be actually trained into helping each other out during a disaster, especially the vulnerable people. For example, children, or for the old people, or for that matter, the Divyangjan, the disabled, etc. Elaborating on these points, learning lessons from the 2004 tragedy, India has established the Indian Tsunami Early Warning Center. The ITWC, the Indian Tsunami Early Warning Center, it's in Hyderabad, under the INCOAS, that is Indian National Center for Ocean Information Services, Ocean Information Sciences. Anyway, it's in Hyderabad. ITWC is based out of Hyderabad. ITWC uses mass media, text alerts, etc. to warn of an approaching tsunami, so that people leave the coastal areas. Now, this is very, very important, that is mitigating the very risk of tsunami. Experience from the 2004 tsunami tells us that coastal vegetation like mangroves can break the force of waves. We would like to repeat it, that the natural vegetation along the coast, for example the mangroves, can actually break the force of the wave, in this case the tsunami, saving lives. So the natural vegetation should be conserved and even regenerated. Fortunately, we have real life example of this, the benefit of coastal vegetation. That is the Pichavaram mangroves in Tamil Nadu. They actually protected the coastal area from the 2004 tsunami. They ensured that the death toll was lowered in the area that actually had the mangroves, in the coast that had the mangroves, Pichavaram mangroves, which are in Tamil Nadu. Then coming to the third point, basically preparation actually. The coastal communities and visitors should have easily accessible information about escape routes. Inundation zoning, we have just talked about inundation mapping, inundation zoning, etc., which is generally considered safe beyond 1.6 kilometer inland and 30 meter above sea level. So if you are, for example, if you are told during a tsunami alert that you have to move away from the coast, please try to move as far away from the coast. Generally 1.6 kilometer, that is 1 mile, is considered a safe distance from a tsunami, from you could say developing or approaching tsunami. Similarly, if you cannot move, for example 1.6 kilometer away, try to move, you could say up a building, for example a 4-floor building or even higher. Moreover, people should be encouraged to help each others and the vulnerable. For an example, as we have just talked about, vulnerable people, for example children, the older people, the disabled, etc. Moreover, people should be actually trained to maintain their composure. They should not they should be told not to panic, because panic can lead to some unfortunate happenings, for example stampedes. So this was all on India's vulnerability to tsunamis, and moreover what can be done before a tsunami, during a tsunami, so that we can actually reduce the loss of lives due to a tsunami. This is all for today. We would reassemble for the next lecture in a few days. As usual, we wish you all the best. Thank you.